Welcome back, folks. We're in section 7.4. Today we're talking about ellipses or ellipses, depending on how you choose to pronounce it. And this is the third of the four conic sections we will be studying. We've already talked about circles and parabolas, and now we are into the third one, ellipses. Okay, so here we go. A lot of definitions in the gray box that go with these two pictures. So I want you to pause the video and read everything you see and try to make connections between what you see here in text and what you see here in pictures. So do that right now, please. So we got the text and we got the pictures. So pause the video right now. Okay, so hopefully you paused that and read through everything there. Let me go ahead and highlight a couple things. First of all, the definition. The definition says that for any point on the ellipse, let's just pick a point there and we'll call it, x comma y. For any point on the ellipse, the sum of the distances from that point to each of these fixed points is a constant. And that constant here is called d. So if we call this d1 and this d2, we can say distance 1 plus distance 2 equals that fixed distance d. Now, really, we're not going to talk about d that much, other than that is the definition of an ellipse. From this point forward, we won't really see that d anymore. Okay, so standard equation of an ellipse looks like this. Hopefully you see some similarities to the circle equation. We still have an x minus h and a y minus k, each of which is squared, and h comma k is the center of the circle. Center of the circle is h comma k. Now we have these two new things, though. These divisors here, our denominators are a squared and b squared. One thing that sometimes students are confused by, if a squared is equal to 16, that doesn't mean that you square 16. So if a squared equals 16, that means a equals 4. Okay, so I saw some students in the parabola unit and the circle unit that were confusing that concept. So if a squared is 16, that means a equals 4. It doesn't mean you're going to square 16 again. So let's take a look here. If we have these two inequalities. If a is greater than b, so if this denominator is bigger than this denominator, the major axis is horizontal, and the foci, or that's the plural of the word focus, lie to the left and right of center. So this ellipse right here shows a major axis that is horizontal, so that means the quantity a must be bigger than the quantity b. And then we have a minor axis that's vertical. You'll notice that major axis contains 5 different points. The 2 vertices at each end, that's where the ellipse intersects the major axis, the 2 foci, and then the center. Next thing we're going to talk about is this value called c. C is the distance from the center to the foci. So in this picture up here, actually I'll go down here and talk about this picture here right now. The distance from the center to the foci is right here, this highlighted distance here. And that is c is equal to the square root of the big denominator minus the small denominator. And you might be asking yourself, why didn't he say a squared minus b squared? Well, because b squared might be bigger than a squared, and then you have to reverse the order of those two things. So I just said it's the bigger one minus the smaller one, and then you take the square root. Remember, if the b squared, if b is larger than a, then this entire ellipse here would be rotated so that the major axis was vertical rather than horizontal. Okay, next thing we're going to talk about here is eccentricity. So eccentricity of an ellipse is the ratio of the distance from the center to the focus, that would be this yellow distance right here, divided by the distance from center to vertex, that distance right there. Okay, so that ratio has a range. It has to be bigger than 0, and it has to be less than 1. Now, the closer it gets to 0, the flatter the ellipse gets, so the more squished it gets. The closer to 1 it gets, the more circle-like it gets, so the less squished it is. Last thing I'll talk about here is this idea of a guide rectangle. The guide rectangle really is just an outline that gives you a boundary for the ellipse. The ellipse falls within that guide rectangle, so that's what the guide rectangle is for. And you draw vertical segments from perpendicular to each axis through the two vertices, and then those two points there on the minor axis. Okay, so let's put this stuff all into play here in example 1. For the equation of each ellipse below, find the center, the lines containing the major and minor axes, the vertices, the foci, the eccentricity of the ellipse. Then we're going to sketch it. Okay, here we go. First thing I'm going to do in this one is I'm going to go ahead and just quickly rewrite this equation. I'm going to write it as x minus 0 squared divided by 4 squared plus y minus 0 squared divided by 2 squared, and that equals 1. The reason why I rewrote it is so you could look back up at the standard form of the equation of an ellipse right here to see some of the important parameters. Okay, so let's start with this. Here we have a equals the square root of 16, which equals 4. And here we have b equals the square root of 4 or 2. Okay, so those two parameters are going to be important for us as we go through and find some of these other items. For the center, remember that the center is at h comma k, and for this, that's just 0 comma 0. Then we're asked to find the lines containing the major and minor axes. Well, we can look here and compare A and B. Since A is greater than B, that means our major axis is horizontal. Okay, so if our major axis is horizontal and it goes through the origin, that means we have an equation of y equals 0. The minor axis will be vertical. Whoa, not minor vertical, folks. Minor axis will be vertical, and we know that a vertical line has an equation of x equals a number. It'll go through the center, so it's x equals 0. So we got a couple more of these questions answered. We've found the center, we found the line containing the major and minor axes. Now we've got to find the vertices. So the vertices in this case, let's go back and look at our picture up here. The vertices are going to be a units away from the center. Hold on, folks, technical difficulties. So for our vertices, we're going to be a units away from the center, and that'll be to the left and the right. So that's going to be negative 4 comma 0 and 4 comma 0. I'm adjusting my center 0 comma 0, 4 units to the left and 4 units to the right. So we're done finding the vertices. Next, we're asked to find the foci of the ellipse. Let's see the foci. Well, that's going to be a little different. That's going to be c units away from the center, and we haven't found c yet. So let's go back up and check our equation here. C is going to be big denominator minus small denominator, and then I have to square root it. So let's do that right now. C equals the square root of 16 minus 4. So that means C equals the square root of 12, which equals, if we put that in simplest radical form, that's 2 root 3. So the foci are 2 root 3 units away from the center, which is at 0 comma 0. So that means I'm going to have one foci at negative 2 root 3 comma 0, and then the other will be at positive 2 root 3 comma 0. Okay, so let's take a look at our list of things here. We found the foci. Last thing we have to do is find the eccentricity of the ellipse, and that's going to be distance from center to focus, which is C, and then distance from center to vertex. And this is going to be, for any ellipse, it's either going to be A or B. In this case, for us, it's A because we have a horizontal major axis. So the eccentricity of this ellipse will be C over A, which equals 2 root 3 over A, which is 4. So that means E equals root 3 over 2. And now, so we found all the different parameters that describe this ellipse. Last thing we have to do is actually graph it. All right, folks, I set up a set of coordinate axes here. I got both the X and Y axes here. I'm ready to plot my ellipse. I'm going to go ahead and identify important points. First of all, we have the center, and then we have the vertices at -4, 0. I'll label that V1, and then +4, 0. I'll call that V2. The foci are at -2 root 3, 0, and if you evaluate 2 root 3 in your calculator, you're going to see it's about 3.5. So my foci are going to be at -2 root 3. I'll call that F1. And +2 root 3, so -2 root 3, 0, and +2 root 3, 0. And I'll call that one F2. Okay, the one thing I also want to do is kind of sketch in the guide rectangle. I mentioned that's we simply take, maybe I can do this with the rectangle tool. This could be a disaster. Let's try it. Kind of gives us an idea of the boundaries of the ellipse. That's not too bad. I'm going to move it this way a little bit. Let's see if I can do this without. Hey, look at that. Close enough for government work. Okay, so now I don't want it to be that big. I'll lighten it up a little bit there, because it is just a guide rectangle after all. Okay, so now inside that rectangle, I'm going to sketch my ellipse, and it's going to look something like this. And that's not too shabby for a freehand ellipse. Okay, that's it, folks. That's example 1A. I want you to take a look at example 1B. Why don't you pause the video, and then we'll see if you can find the same stuff I did. I'm going to fast forward through this one. Okay, folks, there's all the parameters for this ellipse, and a couple things I'll point out. In this case, B was larger than A. That tells me that my major axis will be vertical, and it has an equation. A vertical line has an equation of x equals a number. In this case, it's x equals 2, which is the x coordinate of the center. Minor axis will be horizontal. Its equation is y equals -3. The other things that hopefully you picked up on in terms of watching how I highlighted different numbers here, the vertices are an adjustment from the center, and the adjustment is up and down by 3 units. So the y coordinate changed by +3 units to get 2, 0, and then -3 units to get 2, -6. Same with the foci. We adjusted the y coordinate of the center by adding root 5 to negative 3 and then subtracting root 5 from negative 3 to get those strange looking numbers for the location of the foci. Next thing I want to do here is kind of graph this one on a calculator. So I want to show you that your graphing calculator can graph ellipses. So I'm going to go ahead and start here with a new document. Don't need to save the old one. I'm going to go to graphs. And now, of course, I'm showing you this on the TI Inspire. To be honest, I don't even know if the TI-84 can graph an ellipse. I know it can draw circles. I know that you can certainly graph parabolas. Ellipses, I'm not sure. Somebody, in fact, that's a little fun fact I'd like somebody to research for me. Can you draw an ellipse on a TI-84? Please, the first person that comes back with an answer to that is going to get a trip to the toolbox. Okay, so I can't graph this as a function because an ellipse is not a function. So the thing I need to do here is go change my graph entry edit mode, and I'm going to go to equation templates, and look at that. We have all the conic sections here. Okay, in fact, you can graph a general conic, which we won't bother talking about that right now. We'll use the built-in template for an ellipse. So I'm going to go ahead and select that. My equation was x minus 2 squared divided by a squared, and a was 2, so I better enter it as 2 there, not 4, because 2 squared is 4. And then this was y minus negative 3, gives me y plus 3, and that's over 3 squared, or 9. So I'm going to go ahead and grip it and rip it, and bang, there's our ellipse. And I'm going to use that to highlight the important features for you. I'm going to add a couple things to this before I copy it over to the screen. I'm going to enter a couple equations for you. Let's try y equals negative 3. Heads up, folks, heads up. Okay, I'm going to graph y equals negative 3, and that's going to give me the minor axis. I'd like to change that color for us. Well, that's a nice color. Let's go with orange. Okay, and then I need to graph the major axis, which is a vertical line. So in order to do that on my calculator, I'm going to go to my line template and pick vertical line, x equals c. In this case, x equals 2. And there you go. We have our major axes. Now I'm going to go ahead and copy this over to our notes page so we can put a few more notes on it. Alright folks, I'm back to my notes page here, and of course I have this nice TI Inspire generated image, but you should be able to sketch out something similar. I have my center of my circle at 2, negative 3. I have one vertice at 2, 0, another one at 2, negative 6, and then I have my foci at 2, root 5 minus 3, and 2, negative 5 minus root 3. Now those are going to lie on this line right here, which is my major axes. And if you calculate the decimal equivalent of each of those y coordinates, you're going to get about negative 0.76 here for the first focus, and about negative 5.24 for the second focus. And I think that's about it, folks. We should sketch the guide rectangle on there. Let's go ahead and put that in there real quick. Even though we already have it graphed, our guide rectangle is going to look about like that. Make it a little bit longer, and then we can pretty that thing up by lightening the line and making it gray. There we go. Okay, folks, that's it for this problem. We're going to shut this video down, and you can see page 2 of the notes in the next video.